Now this diagram provides you with a nice graphical display of the whole configuration process from beginning to end. In our case, we're down at the startup region in the far right of the diagram. Startup contains several useful services that most customers appreciate. These include wait for DCMs to lock, which is optional, wait for the DCI to match, which is also optional, negate the global 3 state, that is the GTS, which activates the I/O pins, release the done pin, this is an open drain output requiring external pull-up, assert the global write enable, allowing the RAMs and flip-flops to change state, and then asserts the end of startup, or EOS. Note that the last 4 steps we've just listed, that is, are the default. The most important step here is the release of the done pin. This is, of course, the final confirmation the configuration worked properly. Note that it also needs an external pull-up resistor. In fact, I encourage you now to double-check with your configuration user guide that you have sufficient pull-up resistance on your critical configuration pins. This is also a very common mistake designers will make. Many customers have told us that when it comes to their preferred training experience, they want to be challenged a little bit. Well, we're about to challenge you. This next example is about daisy chaining. Specifically, it's a serial daisy chain. I want to first note that this is not the only daisy chain you can build. As I mentioned, you can learn more about other daisy chain configurations from your device family's configuration user guide. But for now, we want to introduce the concept because daisy chains are used to manage your configuration resources, and daisy chains help you minimize your board traces and minimize the number of proms your system will require. So if you don't recall the basic signal definitions we mentioned in the basic FPGA configuration 1 REL, you may want to refer to your printed copy of that module to answer this question. Or you can simply refer to the configuration user guide available at support.xilinx.com and review the signal definitions there. But with a little bit of extra effort, you should be able to complete our daisy chain we're going to look at in the next slide and understand completely what's going on. So in our first example, the Xilinx Platform Flash PROM is on the left of the system. It is connected to the middle device, which is a Vertex 6 FPGA. The first device has its mode pins all tied to ground. First thing we should ask you is, can you tell me which configuration mode this is in? Well, you should go to the user guide and you can review, or go back to the first REL and review, but yes, it's in master serial mode. Now recall that the first device in the chain must be in master serial mode. You could have found this out from the user guide, or remember that I mentioned it earlier. Each configuration mode has its own unique mode pin combinations. In master serial, all mode pins are tied low. In slave serial, all mode pins are tied high. Note, this can differ by device family, as we'll see when we look at the Spartan 6 version of a daisy chain. Note the connections of each pin in this diagram. We first have to connect the FPGA's clock and program pins to the corresponding pins on the FPGA. The clock pins are tied so the configuration is synchronous to one clock. The program pins are all connected so that the entire system is reprogrammed on command by the user. There's no point in reconfiguring one device. You have to reconfigure the whole system. In this simple example, it's not possible to reprogram one FPGA without reprogramming the others in the chain. Since this is a serial daisy chain, the data from the PROM goes to the first FPGA, that's the device in the middle, and then the data out pin from the first FPGA will connect to the second FPGA to its data input pin, and so on if there are more FPGAs in the system. This assures that the first FPGA will be programmed to completion before passing the bitstream to the next device without corrupting the bitstream. We also have connected the init pins together. Tying the init pins together allows for error checking the entire system since they are all tied together. If one is clearing, the node is pulled low and configuration of the system is not allowed to continue until all the FPGAs have been cleared. Then the node can be pulled high by the resistor. Likewise, later when the FPGA is loading its bitstream, a nit can go low on any one of the FPGAs, indicating that the bitstream has failed its CRC check and the configuration is being aborted. We have also connected the done pins together. Tying the done pins together prevents the system from coming out of configuration until all of the FPGAs are configured properly. Note that you should check your configuration user guide and the datasheet to determine the proper pull-up resistors necessary for this kind of system. Now, conceptually, configuring a serial daisy chain is really no different for Spartan 6. However, there are only two configuration mode pins. In this case, master serial is given the combination 0-1. That is that first device in the middle, while a second device is configured in slave serial and is given the combination 1-1. Now, likewise, when you go back to the Vertex 6 diagram, you'll note that the second device, being in slave serial, now has a different configuration setting on its mode pins than the middle device, which was in the master device. So again, just double check that, make sure you got your devices with the proper mode voltages for your device family. So to review, connect your program pins together. This is required, so all FPGAs will reprogram together. Connect all the clock pins together. This is required, so all FPGAs are synchronized with each other and with the data stream. Connect each data out to the data in of the next device. This is required to allow each FPGA to receive the data stream. Connect the init pins together. This will create a single error flag. Connect the done pins together. This will create a single status flag. And connect the done to the chip enable input of your PROM. As an FYI, check your clock termination and the specifications for the clock signal with the user guide. Again, many customers create problems for themselves when they do not meet their configuration clock requirements. This is probably one of the most frequent technical issues customers experience. They simply do not have a sufficient configuration clock, and the done pin never goes high, and they're not sure why.